Hello dear students, this is Dr. Sourav's class. We are now solving our mathematics optional paper from UPSC 2024. This question is of the Laplace equation and analytic function. So this question is from our complex analysis paper. So what the question asks us, that says if phi and psi are two functions of x and y, that means they are phi xy and phi of x, psi of xy, satisfying our Laplace equation. So what is our Laplace equation? We know that del of phi equals to 0 and our del of psi is equals to 0. And what is our del here? Del is our del square by del x square plus del square by del y square. Okay, then so that if z equals to p plus iq, where I is our root over minus 1 is an analytic function, where our p is this and our q is this. Okay, how can we proceed with it? Okay, so firstly we have to recall the Laplace equation, which I have done here. So now we have to check the analyticity of our fz. Let me change my color first. Okay. So now for being our fz equals to p plus iq be analytic, p and q must satisfy the CR equation, the Cauchy-Riemann equation, you know. And what is it? It is del p, our del x is equals to, and to be analytic, this condition is always will be satisfied by the given function. You have to remember this. Okay. Now we are gonna substitute the given values. That, let me again change my color. Yeah. So our p is our del of phi by del y minus del psi by del x. Sorry. Yeah. Okay. And our qb del phi del x plus del psi del y. Let me number the equations. Let us take it our equation number 1, and this is 2. Now from 1 we get del p del x is equals to our del x of del phi del y minus. So as the partial differentiation, we know we have to take the partial derivative with respect to x for the terms when the minus is occurring here. Our del phi del x this. So now this is equal to what? This is equals to our del square phi by del x del y minus, it is what? Our del square psi del x square. Okay. Let me number this equation. On another color, this is our 3. Now our from 2 what are we getting? From 2, yeah, our del q from 1 the second side, Okay, this thing will appear lastly. There is no need of them now. Okay, now I am only calculating my, sorry, del P del Y to put them in our equations. So our del Y is equals to now, yeah, just putting the values in here and doing the partial derivative with respect to Y now. Yeah, then the same thing happens for the upper thing which is done before, and this will be my base and minus del Y, it's del phi x. So now this is our base, yeah, minus, okay, now let us name it 4. We are gonna having the 4 equations here. So now 3, 4 and 5, 6 will come up. Now I am finding our del q del x. After all the findings, the magic will happen. So now what is my q? My q is this. Okay. Our del phi del x plus it will be our del psi by del y. And then as plus is my in between, so we are gonna distribute that. Yeah. Then it will equals to our del square phi by del x square, then our del square psi by del x del psi. So now this equation will our be number, sorry, 5. Okay. Now we will have another equation that will come from our del q del y, and our del q del y will be del y of the same thing, the same distribution will happen here also. Okay. Now we have to see this from our, yeah, I wanna zoom it. Yeah, from our equation 1 and 2, from equation 1, we will get what? We will get del p del x, that means equation 3, which is our equals to equation 6. So we get del square phi by del x del y minus our del square psi by del x square, which is equals to our del square phi by del x del y plus our del square psi by del y square. And from our equation 2, what will we get? From our equation 2, we will get that equation 4 equals to minus of 5. So our del square phi by del x del y minus del square, that will be psi, no? Psi del x square, which is our minus of, yeah. Okay, let me write it first. Minus our del square phi by del x del y, which is our equals to del square phi del x del y minus of del square phi and del y square. Okay, now what can be done? Okay, so thus sorry, thus the first Cauchy Riemann is held here and the second Cauchy Riemann is held here. Okay, so yeah, then the conclusion is since our P and Q wanna satisfy the CR equations, then the function which is equals to PZ equals to P plus IQ is which is given in our question. So we firstly are trying to find that if, let me read the question, if analytical Laplace equation and so that fz is equals to p plus iq is an analytic function where p is jato and q is jato. Yeah, so we are done. That's our Cauchy-Riemann equation is satisfied here. So our P fz is analytic now. Okay, where P and Q is this. Yeah, we are done. Hope you understood. Thank you guys.